Hey guys, this is a review of piecewise functions for Calc students. So I'm assuming that you've seen them before, but you kind of forgot how they work. If you need like a full breakdown of them, that's another video, but this is just kind of a quick reminder. So piecewise functions, so you probably already know this, they look like this. So they're two different functions or three different functions or seven different functions, however many you want in one. And then when you graph them, it looks like this. So it's in pieces. So piecewise, we're not that creative sometimes when we name things. Now here's a common misconception though about piecewise functions. So a lot of times people think that it has to be like a function on top of itself like this, right? Where, you pick up from one spot to another. And that's not totally true, and that's kind of what I want to show you in this video. So anything goes with piecewise functions. So you can have things like this. You can have more than two functions, right? They don't have to be lines. So this is like curves, so this might be something like x squared. But you can also have super wacky things that can happen with them. So you could have a situation like this. So just take a second to appreciate this. It's like I stop here, and then I have this gap, and then somehow I have this point. And then I have a little piece of a graph here, and then it picks back up here. So I'm actually going to show you how to get everything like up to this, and hopefully like just really review how anything can go with a piecewise function. So I want to start with the basics first. And by the way, I have guided notes if you want to like kind of play along here. So this is the most basic one. So we're basically going to be graphing these two functions according to kind of this criteria. So 2 is a constant function, -3 is a constant function. So this will be a nice one to work with. So I'm going to use the pink color for the 2. So basically what this is saying is that we're going to have the constant function of 2 for all x's greater than or equal to -3. Now, rule of thumb here. Greater than or equal to or less than or equal to. So that means that the point is included. So use a closed dot. And then less than or equal to or greater than or equal to, that means that at that point you use an open dot. Okay, so that's your first reminder. And now the next part of this is, so I need to start this at x equals 3. Okay, so to go to x equals 3, here's 1, 2, 3. And then I'm just going to get up to 2. So here's where my constant function would start. So right here. And so I need to go in the direction of x's being greater than 3. So that would be over this way, right? So these are where all the x's are getting bigger. So I just need to really continue this constant function, which looks like this. So there's x's equal to -2 for x is greater than or equal to 3. So now I'll use the green color for the next one. So one thing that throws people off a lot of times, what do you do here? So you actually are still going to draw something at x equals 3. It's just going to be an open dot. And so the idea behind that is you want to make sure you're capturing all values that come just up to 3. So that could be like a decimal, like 2.9999999, something really, really, really close to 3, right? So to do that, that's why we use the open dot, and that's why we have to actually start it at x equals 3, because we have to make sure that like we get as close to 3 as possible, and the way we get to close to 3 as possible is with the open dot. So I'm going to come down to x equals 3 again, except now I need to use the constant function -3. So if I come down to 1, 2, 3, here's where the constant function of -3 would be right here. It would start here. And I need to continue this for all x's less than 3. So that's going to be everything going this way. Okay, so I'm going to go this way. And there you go. You got two constant functions. And the kind of the breaking point is at x equals 3. So you can see here, 3 is not included here, but we're coming up to this point, and then we jump up to the other function. So the domain of this would be all real numbers, right? There's a function for all of these. And okay, I think that's it for this one. Let's pivot now to the more complicated situation. So the rest of these I'm going to do with 3 functions because I think it really helps the review. So I want to challenge you actually to maybe pause and see if you can do this on your own, and then hit play when you're ready. So I'm going to start, I'll do the 4 with this blue color. So this is again a constant function here. So I just need to go to where x equals 2. So here's x equals 2, and I'm going to come up here for 4. Here's the constant function of 4, and then I'll just continue it for all x is greater than 2. So it's just going to go that way. Okay. So now I need to work on this function x plus 2 between -1 and 2. So you're going to be leveraging what you know about each one of these functions. This is just a line, right? This is in the mx plus b form. I have the slope. So really, if I know one point, I can probably draw out the next part of this, or you know that you have kind of two endpoints here. You need to start this or really you need to end this at x equals 2 and then begin it at -1. So let's figure out what's happening at the endpoints here. So let's see, I'll use the pink color. So let's figure out what happens at x equals -1. So at x equals -1 for this will be -1 plus 2. So this equals 1, okay? Now I also need to know for this function what happens at 2. So if I use x equals 2 and just plug that in, I'd get 2 plus 2, so that equals 4. Now there is a difference though. At -1, so notice you have the less than or equal to, so -1 is going to get a closed dot, while the other point, so here at 2, this is a less than sign, so this is going to get an open dot. Okay, so I'm gonna plot both of these points. So I have the point 2, 4, so I'm gonna go ahead and put an open dot right here. And then I have the other point, so let's see, -1, 1. So -1, 1 right here, and that's a closed dot. Now one other thing I want to point out as I connect these. So notice that this should have the slope of 1. So I could also count this to like double check that I did this right. So if I go up 1 over 1, so let's see if I go up 1 over 1, up 1 over 1, and then up 1 over 1. So see how these all connect? So I just kind of, I'm like very sure of this. So here's this line segment. I'm trying to draw it as nicely as possible. Okay, so there's that line segment there. So I want to point something out. In this case, we had an overlap. That's totally fine. That can happen, and if it happens, it happens. So that just means that right now this little piece here is just going to all be continuous. So now I'm 2 parts down, so now we're going to do the last part. I'll do this last part in green. And now I need to know what's happening at -1 for this function. So I'm going to use x equals -1. I'm just going to plug that into this function because I have to know what's happening here. So then this is going to be, let's see, this really just becomes 2 plus 1, so this is equal to 3. So I'm going to go to -1, 3, 1, 2, 3, and I'm going to put an open dot here. It's open because it's the less than sign, so this is an open dot. And then really if I want to get the next points of this, I can just leverage the slope. So I have 1 point. If I count out more points, so normally I would go down 2 over 1, but this needs to be for all points less than 1. So I could go just this direction instead. So I go up 2 over 1 like this. Up 2 over 1. So I'm just using the slope to help me figure out some other points. Now, if you don't want to use this, if that's confusing to you, the alternative method for this is just choose another point that you know that this line's going to hit. So as long as you have any x's less than -1, you're going to be on this line, right? So if I wanted to figure out just a second point for this, so let's say I wanted to use, what if I wanted to use x equals -2? So -2 is less than -1, right? That's why I chose it. You could have chosen anything. So just in the interest of finding a second point that's on this line, I'm just going to plug -2 into this. So now I've got -2 times -2 plus 1, so that gives me 4 plus 1, so that'll be 5. So then I can just go to -2 and then go up to 1, 2, 3, 4, 5, which is exactly what I had. Let's see, I think I miscounted. So let's see, -2, 1, 2, 3, 4, 5. Sorry, sometimes my scale can be a little bit off since I hand draw things. So that would be an alternative way. So you can either use the slope to count out a point, or you can just find a point by plugging it in, if that makes sense. So there you go. So there's my whole little function. And so I've got 2 pieces that these are not connected, but these are, so anything goes. Okay, so now in this vein of anything goes, so now let's make it harder. So in this function, so I want you to take a second to appreciate it. So I've got constant function x squared, but notice what's going on over here. So this is for x's greater than 4, but then notice that this constant function 2, this is between -1 and 1. So there's actually going to be a gap from 1 to 4, right? There's no values accounted there. And then from -1, we're going to jump onto x squared. The other thing I want to point out, so notice that for both of these signs, this is less than or equal to, this is less than or equal to. So like I said, anything can go with a piecewise function. You don't have to have something perfect like this last one where, okay, from -2 or from 2, now I'm going to jump to this one, and then at -1, I'm going to jump to this one. And it's not like you're guaranteed to have closed dots. So literally anything can happen. So let's start with kind of the simplest one first. So maybe you want to pause the video and try this yourself. So just graph the first one and then hit play when you're ready. So I'm going to start here. So I'm going to come over here to, let's see, 1, 2, 3, 4, and then I'll go up to 3. So let's see, 1, 2, 3. And this is going to be an open circle, right? Because this is greater than. So I need to do this for all x's greater than 4, and this is just the constant function, so it's going to go like that, okay? So now, let's move on to the next one. So again, maybe you want to pause the video here to try this on your own. So now I want you to graph the constant function of 2 from -1 to 1. And you can hit play when you're ready. So let's see, from -1, so at -1 I'm going to have an open dot, and then at 1 I'm going to have a closed dot. So notice the difference here. This was a less than, this was a less than or equal to. But this is just the constant function too, so I'm just going to connect these 2 points, and so there's the middle function. So this has a big old gap from here to here, and that's okay. That's what this function says. And now for this last one, so it says then I need to jump onto x squared. Now for this, you might need to come up with a couple different points to figure this out. So go ahead and hit, oops, I'm sorry, this one was done in pink. So you can go ahead and pause and try to graph this and then hit play when you're ready. So let's see, I need to figure out what's happening at -1. So if I plug in -1, I'll get +1. I'm going to plug in a second point. So at -2, I'm going to get 4. So 1, 2, 3, 4. So I know that x squared has that curve shape, so I just want to make sure I reflect that. And so there you go. So that would be this particular piecewise function. Okay? All right, so for the last one, so this one is another kind of wacky one. So I actually want you to pause the video here, try this one on your own, and then hit play when you're ready. Okay, so starting with the first piece, so this is for x is greater than or equal to 3. So I just need to plug in really 3 into this to start. And so let's see, if I plug in x equals 3 into this, so I get 3 times 3 plus 1, so that's going to equal 10. So these hash marks this time, I'm going to have these stand for 2s. So 2, 4, 6, 8, 10, just to make my life a little easier. And I'll do that here too. So we'll do this 2, 4, 6, 8, 10, so I can just graph more. Okay, so I need to come here to where x equals 3, so that would be right here in this case based on my scale. So here's the first point that I'm going to graph. So I'm going to come up here to x equals 3. And so now to get my next point, I have options of how to do this. So I can either, like, as I look at this, this is a line, so I could just count out the next point. So I could go up, 1, 2, 3, and then over 1. That would be fine. Or if you want, you could just plug in another point that is greater than 3. So if I wanted to use like x equals 4, I could plug that in, and I'd get 13. So whichever way you want to do it is fine. But so the way that this is going to look, so let's see if I extend this. Let's see, I think I can do this as is. 4, this is 12, so this would probably be 13 right about here. So here's that line. Okay. So now let's move on to the next one. So this one is for x is less than -2. So this one's going to have an open dot. So, all right, I need to know what's happening at -2 though. So I'm going to use x equals -2. So this is going to be -2 plus 1. So this is going to equal -1. So at -2, so here's -2, I'm going to be down here at -1. I'm going to have an open dot. And then if I want to choose, again, you can use either the slope, or if you just want to choose a point that's less than -2. So if I chose, say, like x equals -3, so I have -3 plus 1, this would equal -2. I could just do this and do this. So I have something that looks like this. So I have a line. Okay, so here are those two pieces, and they are definitely disconnected because this is for x is greater than or equal to 3, and this is for x is less than -2. So then you have this weirdo thing in the middle. So this says you need to have the point 3 at x equals 0. So you have this big old gap in here. What do you do with it? Well, you plot one singular point at 0. So let's see, I will do this in this pink color. So here's 0, I come up here to 3. That's all you can do for that one. So it's kind of a crazy looking graph, but it kind of illustrates this idea of anything goes. So you really have to pay attention to kind of these, and then leverage what you know about these, and you kind of combine everything at once. So hopefully that was helpful. If you have other questions, you can feel free to drop me a comment. If you like this video or you subscribe to my channel, that helps me out quite a bit. I'm trying to provide quality free help for calculus and other classes on the internet, so every little bit helps. Thanks guys, I'll talk to you next time.